back, and if you want to go back and review over section D, and it will be posted. Okay. I start off with that we're going to go into inspection, repair, and metallic aircraft structures, section D. And to be honest, I have a hard time trying to go through this. Why? Well, how long have you been doing sheet metal? Well, I counted the days. This is our 10th day. So if you subtract today, because we're not physically in the shop, the first 2 days we were lecturing. You've pretty much been in the shop for roughly 7 days. Is that much time to learn sheet metal and then to say, okay, now we're going to get into how to, assess the damage and try to come up with everything. How long would it take to repair, and, where's all the damage and stuff? To be honest, no, it's not. Okay. If, hopefully nobody has had this situation, but if you've ever had a situation where, say, you got into a car accident, your car was damaged, many times, an insurance adjuster will come out to take a look at the vehicle to assess the damage, to say, okay, it's $2,000 worth of damage. Has this ever happened to anybody?
Yeah.
Yeah. Did the assessment come out truthfully?
They're always lowballed. They're always under, and you got to get supplemented.
Right. Okay. Now, I'm not going to say they do that purposefully, but a lot of times, just until you open it up and you start, taking it apart, you can't really see where all the damage is. Does that kind of make sense?
Yeah.
Yeah. And so to try to go through and what to look for and, all these little details, we're learning how to properly shoot a rivet, than to really diagnose everything. So I'm just letting you know, for a person to be really good at sheet metal, they have to have, and I'm serious, years of experience. Okay. They've had to be doing it for a long time to get that experience, to be able to diagnose or to examine parts to see what is it going to take to repair, what is the extent of the damage. Does that kind of make sense?
Yeah.
Okay.
Yeah.
So that's why I'm going to say, it's, it's really hard to go through this and stuff. In fact, I think I'm going to tell a little story just to get us going. All right. So I'm going to, you can probably see me. I need to go here. Hello, I'm in my office. Okay. And I'll give you an example of trying to assess damage. Okay. Where I worked, we were an FBO here on North Perry Airport. We were a repair station. We were a flight school, and we also rented out aircraft. Well, a gentleman that I knew, customer of ours, he had rented out a Cessna 172. And he comes back and he comes up to me and he goes, "Hey, Bob, got a problem." "Oh, what happened?" He goes, "Ooh, I hit a bird." Right now, to be honest, hitting a bird here at North Perry Airport was, it wasn't an everyday event, but it was not uncommon. And you usually, okay, dent in the wing, leading edge. Sorry, I don't know if you can see what I'm doing. Let me see if I can move that more. Yeah. I want rid of that. Okay. but usually, okay, the leading edge has been dented. And we've done repairs like that before, and primarily we undo the leading edge. Either we form it by rolling a new piece and then riveting it up. Not much of a big deal. Well, I'm like, oh, okay. So I go up to the we go up to the aircraft, and it was on the left wing. And as I'm walking up to it, it wasn't like just a small little dent. I mean, it was really pressed in. And I'm like, holy cow. I mean, what kind of bird did you hit? It must have been huge, And as I get up to the aircraft, I see like leaves of a tree and a little bit of a branch. And I looked at him and he goes, oh, the bird was sitting in a tree. Hello?
Yeah, we're here.
Sitting in a tree.
Bird was sitting in a tree. So there was an airport which was known as Opelika West, just west of North Perry Airport, a little south, but north of Opelika Airport. And it was an uncontrolled airport. It just basically had one runway. And there was trees running all along the north side of the runway. Well, people go over there to do touch and goes and practice what's called touch and goes, where they come in, they land, and they, don't stop, and they take off again. And I guess what happened was, as he was flying, he drifted off, and I don't actually know if there was a bird in the tree, but he hit the tree, which then put this big dent into the wing. Okay. Now, as I said before, I've seen bird strikes on wings before, and generally it's limited to just the leading edge, and where then we have to repair that leading edge, mainly by just removing and replacing that skin. Sometimes there's what's called false ribs, which is to maintain the contour. If it hit one of those or damage that, we replace that. But in this case, it hit and made it big. Now, at first, yes, we're concentrating at what you could see right there where the impact was. But we started thinking about it and go, if that wing got hit here, what's going to happen? Anybody? What do you think is going to happen to this wing if you get hit way towards the tip?
The stress is at where it hit intersects the plane.
Yeah, at the what's called the wing root. So we start looking at it. We start removing different fairings and stuff. And what happened was the front spar and the rear spar, those are the two main structural components of the wing. Actually, what happened was the wing went backwards. Okay. And so it actually bent and cracked the forward spar and the rear spar. Okay. Now, could you see that damage from outside the aircraft just looking at it? No.
No.
You had to actually tear in. And if you think about an aircraft wing, we're talking, we see the damage, but the more critical damage was approximately 15 feet away. So, when you are trying to assess that, we really have to take into account and look at the bigger picture of, okay, if it's damaged there, where else could that affect it? Because just because it got hit one location, that could have put stress somewhere far away. Does that kind of make sense?
Yeah.
Does.
Okay. And I'm going to get back to that story later on what we did for that repair. All right. So. Okay. So this is why I say, when we go into repair of sheet metal structures, repairability of sheet metal structures. You can read through it. I mean, not too many years ago, major sheet metal repairs were done in most aircraft maintenance shops. I'm not going to read it to you. Understand that, and today's going to be more storytelling than anything. Depending upon the shop that you're working in, determines, pretty much how well can you do the job. To do sheet metal and to do it well, and to be efficient at it, you have to do it every single day, okay? And where I worked, for example, we would have sheet metal repairs to do, it's common, but, at one time I had over 10 mechanics working for me. And if I gave a sheet metal job to one mechanic and then the next sheet metal to another mechanic, by the time that first mechanic got another sheet metal job, it could have been a month or two away. Okay. And so that did not make our shop very efficient on sheet metal repairs. So we decided, the director of maintenance and myself, I was the chief inspector of the repair station, that we needed to dedicate one person to sheet metal repairs. And that way that person would become very proficient, and wouldn't take as long as others, trying to do the job, and it would come out better. It's a more efficient way to do it. So we were going through the mechanics that we had to see who would be probably the best person to choose to do this job, or to be our dedicated sheet metal person. And
Sir, sorry to interrupt you. Just want to tell you that Justin is trying to connect, but is having issues. So it just wants to let you know.
who is?
Justin,
Okay, because I see he's in, Justin Cummins.
I guess, yeah.
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 I see him there.
Okay,
Oh.
maybe got in.
Okay, yep, he's still there. Justin, you there? I still see him online, so. I didn't get anything that's like, usually it'll say something like, hey, as a guest or something. Okay, I'm going to keep on going. If he contacts you again, let me know, please. Okay, so we're going through the different mechanics, and we had a person, his name was Ken. And Ken did not have his airframe license yet. He was actually still going through A&P school. And so it was like, we think Ken has the mentality to be a good sheet metal mechanic. How can I don't like to say this, but I'm not a very good sheet metal mechanic. Okay. I don't have the patience for it. I know how to do it. I just don't have the patience for it to be so, it's just me. It's not my characteristic. Anyways, I love sheet metal, but, that's all I'm going to say. So anyways, I brought in Kenny, and with the director of maintenance and such. And I was like, well, Kenny, I got good news for you. You're going to be our dedicated sheet metal mechanic. And I start going through it, and his reaction was unbelievable. It was like, oh, hell no, 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 no. And I'm like, well, why? What's wrong? He goes, I failed sheet metal twice already. In school, he had already failed sheet metal twice. And to be honest, I was like, I don't care. You have everything that it takes to become a good sheet metal mechanic. So he kind of fought me initially, but what I would do is, okay, here's a problem. And I would go through how to do it, how to look it up in the AC 4313 or the maintenance manuals, blah, 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 how to design the repair and such. And then watch how he did it, helped him if he had any questions and such. He ended up to be a very good sheet metal mechanic. I just remember one day when one of the other mechanics is like, "Hey, Bob, there's some sheet metal damage. Will you come take a look and stuff?" And I looked at the damage, and I think I estimated that, okay, this probably will take about 4 hours to fix. I brought Kenny over and said, "Okay, here's the problem, blah, blah, blah." And he looked at it and stuff. He's like, "Oh, no problem. All right." Not even, I'll give him an hour. It was about an hour later, he comes back and goes, "All right, that's done." I go look at it. Just such a beautiful job, everything to the letter, no problems and stuff like that. And, that's what happens. If you do it enough, you kind of learn the little tricks of how to do it better and cleaner, and, take your time, but it takes a lot of experience. Are we good with that?
Sure. Do they still do that? Do they assign you to specific
Some shops, yeah,
job?
but there's
Okay.
also specialized shops that's all they do is kind of sheet metal repairs. But it depends on where you work. If you talk about the airlines and that, oh no, if you go to the airlines, a lot of times you will start in the sheet metal shop first, because that's where the most of the work is. All right.
Yeah,
So to kind of hit some of this, I'm just assessment of damage and that, like I said, just because the aircraft is damaged in one location, we have to realize that could have put strain and stress on other areas around that area, or actually kind of far away, attachment points. So we need to investigate those areas to make sure everything is good. Under inspection of riveted joints, there's a thing called rivet tipping, okay? And what that means is, and I know this is kind of a little weird, is that, if we had rivets here holding two pieces of metal together, and I know we don't have the second piece here, but say there's, this seam or something like that. If one piece of metal has been pulled one way, and the other this way, creating a shear load to that rivet, the rivet may have been stressed, but not stressed enough where then the rivet has actually physically failed. But what we'll end up having is, and this is an extreme case, what's called rivet tipping, where then right here, you can see where the head of the rivet is laying flush against the skin. In rivet tipping, the head will actually tip up away from the skin. And that is a good indication that there's a lot of stress and that has been stressed. So when we are removing rivets in this particular area, okay, one of the things we want to look for is the holes, okay? And that what will happen is when you remove the rivet, the hole will misalign. That's showing that, that the metal was still under stress and strain, okay? Eventually, once you remove enough rivets, you will see the holes stay parallel to each other, or they won't move anymore. And that's when you know that you've removed enough rivets where there's no longer any stress trying to pull it apart, okay? And those are called tipping rivets, okay? Of course, we always want to inspect for corrosion if we're doing something, because, a lot of times there's some hidden corrosion and such. And I'll talk about that a little bit shortly, because as I said, it's going to be more stories and stuff, but I want to kind of get through what the book has first. All right, repair of negligible damage. What they're showing here is pretty much Here's been a nick in, that hasn't really penetrated the skin very much and that, but even that, we don't want to leave it because this is where corrosion, stress cracks can start. So we want to burnish that out. And what that means is we don't just want to fold that like lip back down because that creates an inclusion. We actually want to dig it out and smooth it out so that there is no stress risers coming from that would concentrate the stress and create a crack. Okay. Now, on page 296 and 297, they go into they specifically say specific sheet metal repairs. And to be honest, folks, majority of the time, we do not design the repair ourselves, okay? Majority of the time, what we try to do is find an approved repair that has already been designed. Now, the question is, I kind of jumped, but understand that there are what's known as minor repairs and there are what's called major repairs. Does anybody remember major repairs? Have you
Has to
ever
do
heard of
something
major repairs?
With the seams, if it's like, if you have to do, affects the seam, something like that?
Okay, okay.
Yeah,
Alright.
it's something that could dramatically, impact the airworthiness of the airplane. So you can do the repair, but
Right.
you need to submit a Form 337 to the
Okay,
FSCO. And
very good, very good. That's the part that, yes, a major repair alters the aircraft so much that basically it needs to be repaired, but it has to be repaired very specifically and has to be approved by the FAA. Okay. Now, I'm going to kind of go through major repairs. Ready? If you look at an aircraft, right, you see damage. Where could you find what is considered a major repair? What FAR would tell you what is a major repair?
Part 43.
Okay, FAR Part 43.
Appendix
That's the
A.
FAR, and it's under Appendix A. Okay, so if you're doing a sheet metal repair, we should always go to FAR 43 Appendix A. Appendix A lists all the major repairs, okay, to both the airframe, the power plant, the propeller and such, okay? And it gives you criteria of what is considered a major repair. For example, like splicing of a spar, putting additional splices where there was no splices, okay? Can all be considered a major repair, okay? Now, here's the question. If you're doing a major repair, what type of data do you have to use? And I'm just going to go through it. The type of data that you have to use is what's called approved data. Now, one of the crazy things is that most of us would think that the maintenance manual of the aircraft is approved data. And it is not approved data unless it has been approved by the FAA. Well, how could you tell? Well, the manual should have a stamping that says approved by the FAA, okay? And generally, every page is stamped with that, saying that it's approved by the FAA, okay? So to do a major repair, we have to use approved data. Now, most aircraft manuals, sorry to say, are not approved data, okay? But what things are approved data? Well, airworthiness directives, ADs are approved data. Type certificate data sheets are approved data, okay? The only problem with those types of approved data, they don't tell you how to repair an aircraft, okay? Now, for non-pressurized aircraft, we have the AC 4313, which is the acceptable methods and techniques. Now, that manual is acceptable to the FAA for repairs. But is it actually approved data? And there's a little caveat to that, in that the AC 4313 can be used as approved data as long as certain conditions exist. One is that it is not contrary to the manufacturer's data. Or if there's no manufacturer's data, then you can use it as approved data. And also if it's directly applicable to what you're doing, okay? So there's, in the AC 4313, at the very beginning, kind of like the first paragraph, tells us the certain criteria that we can use the AC 4313 for, as far as approved data. Now,
Can I, ask a question, Bob? So in the, the FAA test questions prepware, I think they say though, right, the answer to the question is AC 4313 approved data. The answer is no, right?
is what?
Is no, it is not approved data, but I guess you're giving us those few exceptions where it is.
Right, right. Just by itself, it's acceptable data, okay? But in the preamble, it says that it can be used as approved data if the criteria is met. There's no manufacturer's data. It's not contrary to manufacturer's data, and it's directly applicable to the, say, the repair.
And can you distinguish, right, each airplane has a maintenance manual, and you've already said that in some cases you may have stamps on these pages that
Right.
indicate that it is approved data.
Okay, like on, let me go through and maybe I'll answer your question with it. Okay. So like, for example, on small general aviation aircraft, Cessna does have a repair section, although it's not necessarily approved data, but it does cover the majority of the repairs that you would do. If you were to do a structural, meaning a major repair, okay, you would use the AC 4313 because the manual does not show you the major repairs, if that makes any sense.
Right.
The Piper did something very interesting in that when you go into their repair section, they say use AC 4313. By them saying that, that automatically makes the AC 4313 approved data. So for small aircraft, AC 4313 is primarily what is used to do the repairs, okay?
Isn't it 400, 12,500 pounds?
Well, yeah, there's a couple of criteria, small aircraft under 12.5, but the main thing is that it has to be a non-pressurized aircraft.
Okay, thank you.
Now, for large aircraft, commercial airliners, pressurized aircraft, like if you go to the 72, 73, it doesn't matter, large commercial, those manuals, they'll have the maintenance manual, but they generally have a separate manual, which is called the SRM. The SRM stands for Structural Repair Manual. And majority of the time, their structural repair manual is approved data. So that's how you would look up the repair, how to do the repair. And when you do what is known as the Form 337 form for major repairs and alterations, that's where you would be able to find the data on how to make that repair. Are we good there?
And just so I'm clear, you said normally for small aircraft like Cessnas do not have a separate structural repair manual?
Majority of them do not, no.
Okay.
That, and especially that they're approved,
Right.
And the reason is it costs a lot of money to maintain records like that. So, I know it's kind of weird. Hey, the manufacturer's manual's not approved, but it's the recommendations, right? And we are to follow the recommendations of the manufacturer. But why, like Cessna and all these companies, didn't make them approved is because then they would have to maintain those manuals, and that would cost the company money over the long run. Where the airlines, they kind of basically force Boeing and everybody to create a structural repair manual and have it approved so that there is no question on how to fix that aircraft. Good.
I had a question. You're saying that not all maintenance manuals are approved data.
Majority
And-
are not approved data.
Okay, and then you said that then in some maintenance manuals, certain sections are approved and are not.
Right, such as the structural repair manual for large aircraft.
And how do you
And how
distinguish?
you can tell is because if you pulled up a structural repair manual, you will see a stamp at the bottom of the page that says FAA approved.
And that stamp will cover for the whole repair manual?
For the structural repair manual, and many times every single page is stamped.
Okay, so that's the way you, it's
Yeah.
okay, that's good.
Yep. Okay, so just kind of real quick here. The maintenance manual generally is not approved data, but then the structural repair manual is generally going to be approved. Okay. On smaller aircraft, if there's no information given, we can use then what is known as the AC 4313, as long as certain criteria are met. Now, when you do a major repair, remember, a major repair is identified in FAR 43 Appendix A. Now, after you complete a major repair, you have to fill out a form, which is called the Major Repair and Alteration Form 337. Now, if you don't know how to fill it out, or if you don't know what to do with it, you can find what you do in FAR 43 Appendix B. Tells us how to kind of fill it out and what do we have to do with that 337 form. Let me ask you, how many copies of the 337 form do you have to create?
2.
2. And how long do you have to send the one to the FAA?
48 hours.
48 hours. Yes. Okay. Very good. Okay. There is one instance in which we have to make 3, and that is if you alter the aircraft and have a fuel tank inside the cabin. Okay. Then you have to make 3. With 2 of them, one goes to the FAA for approval, one stays with the aircraft records. When a fuel tank is installed in the aircraft, then the 3 have to be made. One goes to the FAA, one goes with the aircraft records, and one of the 337s have to stay with the aircraft at all times. All right.
I got lost there. What was it 3 and why was it 3 now?
For fuel tanks that have been added to an aircraft, okay, especially inside the cabin and stuff like a temporary fuel tank, you have to make 3. One goes to the FAA, one goes to the aircraft owner, for the aircraft records, and one has to be maintained with the aircraft. Okay. And the reason is this. This comes back from the drug running days of the 80s. People would put in a fuel tank and say, FAA police would stop and say, hey, you got an extra fuel tank in that, hey, where's your record? I need to see. Oh, they're all at home, safe and sound, because it's advised not to carry the logbooks in with the aircraft. Okay, because if the aircraft crashes and burns, we have no records to investigate. So they couldn't really hold the person having an extra fuel tank. Well, that person usually then disappeared. So what they did was they required to have a third 337 form, and that form had to be with the aircraft so that if I stopped you, let's say FAA police, I could request to see the 337 form for the additional fuel tank. If you did not have that, then we could hold you, for the legal authorities and stuff like that. and just not let you go.
So this third one is the one that's in the aircraft?
That has to stay with aircraft, yes.
Okay, so the other scenario, there was only two, it's with the owner and FAA.
Correct.
This scenario, the third one is with the aircraft. Okay, thank you.
That's only for fuel tanks, yes.
Sir, sorry, I have a question. I know you already repeated that, I think twice, but I missed it both times. So you say repair manuals are not approved usually. Some could be, some are not for
Okay.
smaller
Okay, I'm not saying repair, maintenance manuals.
maintenance. Okay. So in that case, we go to the circular AC 4313.
Right. You could go
Okay.
to the AC 4313, and as long as it meets those requirements,
Okay.
then you can use that.
All right. Thanks.
All right. Okay. When we go to make a repair, like I said, we usually try not to be easy, or to be simple. We try to find a repair that has already been done, and I'll show you what I'm talking about shortly. But right now, okay, we see we have a crack. We say not this, but this. Now, is this one unacceptable? No, it is. It meets all the criteria to do the job. But is it the best way to do it? No. Why? Because here we could have the stress and we could actually create a weak spot or an area that would crack. We would rather have one like this so that the stresses flow around the material better. Okay. Now, sometimes we can't fit this type of octagon, patch into the same place. We might be limited to the space that we have. So this is still acceptable, but it's not the preferred method. Okay. But here's the thing we have to look at, for example, and okay. Let's say that 2-inch crack was right here. Would we really want to try to put a patch right there? You might want to, and that could be what's known as a surface patch. But here's an alternate. Could we go in there, drill 4 holes, and then cut it out? You know how we did the window? Right? Okay. And then what we would do is drill out all the rivets around here. We get a new piece of metal. We slide it underneath, and then we drill, as we back drilled before, and then reinstall the rivets. Now, out of the two, I think just replacing that section is much better than actually putting a splice up on top. Does that kind of make sense?
So you drill the holes and you leave the holes empty.
But you got to put the rivets back in.
Yeah, the rivets round.
Yeah, but just like we did with the window, we cut out the damaged area, but we're doing the whole section here. Okay. And then what we're doing is we've unriveted where the skin is attached to, say, the stringers. Okay. And then we're cutting a new piece of metal and putting it underneath that.
Yeah, it's almost as though what you're describing here more closely restores the original
Contour,
condition.
the look, you don't have this big thing right there.
Right.
Now, the next thing is this. For example, you might actually see that the aircraft is made of individual sheets. So we might have an individual sheet that, is this big. So instead of even doing this, we might actually go in there and say, all right, let me unrivet all this and just put a brand new sheet in. Does that kind of make sense? I'll relate it to this. Your fender of your car gets dented, damaged. Okay, we could go in there, cut out that damaged area and try to weld in a small little piece, or we could replace the whole fender. Many times, doing the whole panel is quicker, cheaper, and it comes out as a better look. You see what I'm saying? Because no matter what, we have to get to the back side. So trying to do, say, a patch on here, we may still have to unrivet all this stuff and then try to re-rivet all that. And it's like, wow, that can be rather difficult. Okay. Now, okay, I'm going back. I'll give you an, okay, story time again. Ready? Okay. Remember I talked about the bird strike and the spar was damaged. Well, we looked at it and it was like, okay, this is a really big job. It's a major repair. And the decision was made. We took the wing off, and there are specialty sheet metal shops that's what they do. They do, the complicated jobs much more efficiently than we would have ever been able to do. So we sent it out to a sheet metal shop. I don't remember the time frame, but I'm going to say it took them a week to do the repair. Okay, they do the repair, we put it back on, the aircraft is back and running. Okay, it actually, I think it was more like 2 weeks at least. But so the aircraft was down for 2 weeks, and it does have an airworthy repair. So the aircraft is airworthy. Okay, everybody good with that repair? Yes?
Yeah.
Okay.
Yeah.
Was there anything wrong with doing that? Not at all. Okay. Now, I'm giving you another thing that happened to us. We found a spar on a Piper aircraft that was corroded. Okay. Now, we could have gone in there and did repairs to repair this. But in this case, what we did was there's companies out there that are basically aircraft junkyards. Now, when I say junkyards, that's kind of gives it a bad name. But what they do is they find aircraft, like when a hurricane comes by, they go in there, and if the aircraft has been totaled or that, they buy it from, say, the insurance companies or buy it from the owners. And then what they do is they salvage all the good parts off of it. So we found a proper wing for that make and model of that aircraft, and we bought it. Okay. So now what did we do? All we did was we removed the old damaged wing and we put on, I can't say a new wing, but we replaced the whole wing. Now, in this case, when we replaced the whole wing, was that a major repair?
Yeah.
I'd say no.
So
Nope, not a major repair. Because all we did was remove and replace a part, a component, okay? We didn't repair that. If we would have repaired the spar, if we would have repaired things, that would have been a major repair. But because we replaced it with an airworthy wing, there was no major repair. Now, let's take a look at the two now, okay? The one was removed and had a major repair done. What do you think happened? One, the cost of getting it repaired. We have a cost of that airplane being down for an extended period of time. And what happened to the resale value of that aircraft? It went down. Okay. Now, with the other one, because understand that major repair is part of the permanent records of that aircraft. Okay. Now, on the Piper, we removed the wing and put a new wing on it. Did that wing cost a good amount of money? Yes. But overall, if we consider how much did the other one cost to get repaired, the downtime of that aircraft, right? But more specifically, the resale value. The resale value of the aircraft that we removed and replaced, here's the thing. Eventually, there will be no record of it because I'm not going to go heavy into this because this is part of, general forms and records. But this is what's called a temporary, repair kind of thing. It's not part of the permanent records that you replaced the wing. And so nobody would ever know that, oh, major repair. And for the fact that there is no major repair on the aircraft. And to be honest, if you had a choice, hey, I can buy this aircraft with a major repair on a spar, or which is totally airworthy, or I can buy an aircraft that has no major repairs. Well, I think most people would choose the one that doesn't have any major repairs. So the resale value of the repaired aircraft is going to be hurt. Kind of makes sense?
Is major repair basically like rebuilt title?
No. No. But do you understand what I'm saying there?
Yes, I have a question for a situation like that where you replace the whole wing.
Yes.
How would you know that the wing that you're putting on it is airworthy? Like that there's nothing wrong with it? Do you have to get it inspected?
Oh yeah, you have it fully, you inspect it. Just
Can
like
an A&P inspect it themselves, or do they have to have somebody else
Oh,
inspect
well,
it?
put it this way, when you're putting it on, or if you're the one that's putting it on, you want to inspect it.
Okay.
You're responsible for that. So, you work with reputable people, but no, you inspect the wing, just as you would inspect a wing if it was on an aircraft, say for an annual inspection.
Bob, I have a question in terms of this figure here. It says in 4313 that anytime you're going to splice additional sheets, a
But in
patch.
this case, we're not splicing it.
Okay, well, but looking at figure 2-14-148 here, right? You mentioned that what you might want to do rather than making a patch is to cut out that entire area in
No, well,
violet.
the whole
and
entire
replace-
area, you mean what I showed in the black here?
Yeah, or.
No,
even
that's
that
where I was
purple area.
saying that was one big sheet.
Okay, well, what about just the purple rectangle there? If you cut out that and replace that, is that a major repair? Is that still
No.
a major repair?
No.
Oh, it's not, okay. Because you're replacing a small section rather than making an additional splice.
Right.
Okay,
Like if this was the big sheet, right? And I sliced it down here, right? Then it is. Because I put an additional seam there in that panel. I know it's not easy.
but I thought that even though that little purple area is small and all we're doing is replacing, that AC 4313 says that anytime you're riveting or welding, that's a major repair, irrespective of how big the area is.
No,
Okay.
no, we can go through that when we get into class to show you.
Okay.
Because you got to go to A and stuff like that. But, and so here's 4313, and this is what I wanted to get to is when you're making repairs, and we're going through, I'm getting to the point here. With the AC 4313, okay. Sorry. I'm getting there. And you can see this where I'm trying to get to. Okay, here it is. Okay. This all right here is how we, or one of the most major ways that we try to identify what we can do. And so, for example, if we had, say, that 2-inch crack, okay? So here's the drawing of the repair for the 2-inch crack. Okay, so instead of us trying to figure it out, we can actually come here, and yes, we will have to do, say, the pitch and stuff like that, because, you know, all the different things. But what I'm saying is, here's the information and what we're trying to duplicate for our repair. Okay. The same thing goes with our circular. Now, circular patches are pretty nice. And, oh, I can't do it here. So I'll have to go back to my other in just a second. But understand that here's like for a 1-inch hole, and that's K, sorry. Yeah, that's K. Or does it 1-inch hole maximum? That's the information to do that. Here's for a 2-inch hole, a 3-inch hole, and here's for what that section is there. Okay. So I'm just showing you an AC 4313 has quite a bit. Okay. Now let me go back. Now, so here's the thing. If we have a crack, just like what we have here, right? Can you see that you have many, many options? We can, one, do the octagon, right, shape, and put in huge number of rivets, like the one that was given to you. We have to put in what, 20 something rivets on each side. Okay, well, and it's hard to flip back, but if we do a circular patch, just because we have a crack going this way doesn't mean we have to do a rectangle or an octagon type shape. What's preferred is a circular. So if, for example, this is an 1.5 inch crack, I could cut that out to a 2-inch circle, and then following the AC 4313, put in the rivets here, put in the rivets there, and it's a much simpler repair, and it actually is a better repair. As I said, also in 4313 shows that, well, we can cut sections here to replace that portion of the skin as a patch. And then ultimately, we could actually remove the whole skin and just replace that skin, bringing it back. Because one of the key components is that, and the biggest mistake people make in making repairs is that they want to make it bigger, better, and stronger than original. And that's a falsehood. We want to bring the aircraft back to its original strength and stiffness. Are we good there?
Yeah.
Okay. All right. So let me go back to 100%.
So before you continue, I'm a little bit lost with the purple patch. I don't understand the holes in the corners.
It'll be easier when on Tuesday when we come in.
All right, sounds good.
It'll be, and because it'll be easy to show it on your project.
Of course. Sounds
All right. Okay. So this is the problem basically that you're doing. Here's the 2-inch crack. You got to go through all of the number 1, 2, 3, 4, 5, 6. That's 6. That's 11, 12, 13, 14, 15, 16, 17, 18. Ooh, that one's 18 only. Yours has more than that, right? But this is what your repair should look like. But you're going to have additional rivets. Okay. In this picture, all they're showing is that sometimes the very edge of the metal, to keep it from lipping up. For example, if we have a skin and we're putting another piece of metal over top of it, right? as a surface patch. We want to bend that down slightly so that no air, nothing gets trapped underneath. Puts a little downforce on that, okay? This is going to be, a circular patch. This is like for a 2-inch, 2-inch diameter. And we see the multiple rows of rivets and such. This is the one that I will be explaining on Tuesday for the repair that we're going to be doing, but we're doing a 1-inch hole rather than the 2-inch. Okay. The rest of this information is all in AC 4313. They just show that, oh, okay, we line up the rivets, we just follow the instructions. If we had an angle, we might, support it then on the inside, right? Or the outside, but we want to back it all up, and depending upon what we need to support and regain that integrity of that part, it can be rather complicated. Okay. Trailing edge pieces and stuff, like I said, there's 100 little things and stuff, but we're just going as we're going. All right, on this, here they're showing, for example, a corrugated control surface. Corrugations are basically, like on an aileron and stuff like that, the metal will have these little V's that go up. What is that there for? It's to increase the stiffness of the metal, just like we put the beads in our bulkhead. Okay. Instead of, to repair it, what can we do if there was damage? Well, if we can get some of that corrugated aluminum, which you can then remove and then reinstall a section of it, or cut the section out and put it in. Yes, that would be major repairs. Okay. Now, to me, what's best is either find a brand new aileron, okay, or reskin the whole thing rather than making additional seams. Okay. Now, in this is doing a.
What is a seam on that picture? What constitutes the seam?
This used to be one full piece. Now it's 2 separate pieces, and you're adding a seam here and a seam over there. And these 2 pieces are not connected anymore, except for this piece.
Oh, the original one, there was no, oh, now I see there's no rivets in the middle. Now there's rivets. Okay.
Yeah. So if you're following the same rivet pattern, and using the same rivets there, you're not making an additional seam type thing. Does that make sense?
Yes.
Okay. So like, this almost goes back to the purple patch when somebody said, well, that would be a major repair. Not necessarily. And here, right, you can see we're cutting the original piece totally. So now there's 2 separate pieces. So now what used to be 1 piece is now actually 3 pieces. And we've added seams. When we took the like in here, we still have the main piece, and where those are riveted, we're just riveting that piece into there. We're not making an additional seam. I know it's crazy. An additional seam would be if we put a new rivet line there straight across.
That makes sense. Thank you.
Oh. Okay. On control surfaces, and this is something that we will actually be doing when we go into what's called assembly and rigging. This is checking the balance of the control surface, okay? So because we do it in assembly and rigging, I'm not going to go how to do it in this class. But what it is that control surfaces, flying through the air can act like a flag. If you ever seen a flag on a flagpole in the wind, if it's a strong wind, the trailing edge of the flag will, what we refer to as flutter back and forth. The control surface could actually flutter if the balance of the control surface is not within specifications, okay? I would relate it to, think if your alignment on your car is off, your steering wheel could shake left and right, okay? And for us in flying, that we would call is flutter, that the control surfaces are going up and down or left and right and such. And this is primarily a problem with the balance of the control surface. Now, if you make, when does an aircraft's control surface the balance have to be checked? Whenever anything could change the balance of the control surface. If you make a repair to the control surface, say adding rivets and cutting metal out and adding metal to it, you're going to affect the balance of the control surface. So the control surface then has to be balanced, or the balance check. When you paint an aircraft or paint a control surface, you have to do a balance check on the control surface. And those are the two primary things. Whenever something is done to the control surface, that could affect the balance. Okay. All right. Inspection panel, nothing special there. Once again, they show a whole bunch of pictures of, oh, here's a little repair. This is how this repair can be done. Okay, we could add doublers in that. And some of them, yes, are major repairs and some are not. Here again, we have a leading edge repair, okay? Now that they've replaced the leading edge, all they're trying to show here is, well, how do you get it to fit nice and tight up against there? Hey, use a cargo strap and pull it nice and tight and stuff like that. Nothing really specific. Again, they're just showing us a bunch of different little repairs, how they can be done. On Tuesday, we're coming in and we're going to do our repair so that you will have a sense of, okay, step 1, step 2, step 3. I know that was pretty short, but really that's what that section is, section D. Sorry. I want to stop share that. Okay, there we go. Sorry, folks. I feel like I'm backwards today on this.